So this is the file that I have created to show the detection underscore mask underscore video. As you can see, I've named it as that. So what I do here is the basic thing, which I import the necessary packages. Down over here, I have defined a function. And after I define the function, what I do is I take three inputs from it, which is the FaceNet, frame, and masknet. Masknet is nothing but just the model that we built, as I showed you over there, using the Keras layers. And frame is nothing but just the CV2 camera we're going to use, and FaceNet is nothing but a standard face detection model. Line number 13 is where I define two variables as the frame.shape. So basically h comma w, which is in the dimensions of it, which is equal to the values it returns respectively. As you can see, it's in the form of an array. Next line, I create a blob of the image, which is equal to cv2.dnn.blob from image, and I give the parameters. So in case you didn't know, DNN is nothing but just deep neural network. Basically, it's a neural networking model that is created by CV2 recently only, and it's used for anything like processing images and everything like what we are doing right now. We pass in the frame, we pass in the number of blobs, we pass in the dimensions of it according to the blob we want to create, and we pass in the dimensions. And just so you know, these are not random values. So what I do over here is set the input of FaceNet as the blob, and what I do is I forward that input to detections, which is another variable I defined right over here. Next, I initialize three variables as empty arrays. Line number 24 is where I'm going to explain to you guys about detection. So over here, let me just change the name of it so that it matches this. So as you can see here, it has 4 indexes. So basically over here, the first input is null, second one is the frame, and the third one is nothing but just the objects that are detected, while the fourth one is an index for a subset or like another array. So as you can see here, I put 4 here in this note, which is referring to 0, 1, 2, 3, 4, which is referring to this y coordinate. So that's the index of all these arrays for detections. So now I'll make an iteration which goes through all the values of detections made. As you can see, it's saying 2 over here. So I loop through that and extract the confidence, which is the probability of whether an object is being detected or not. So like I said, it's referring to frame 0, and the 0 is null, so you can leave that out, and 2, which is 0, 1, 2, which is referring to the confidence, the detection probability. So if it's greater than 50%, the confidence, what I do is I define a variable called box, and what that is equal to is the detections made of all the objects, and then I equate this, and then I write this value, which is 3 to 7, which is referring to all the values from x to h. As you can see, this colon does that. And then to rescale it back to its original size, I multiplied with this numpy array of width, height, and then width, height. And this corresponds to this, while this corresponds to this, and this corresponds to this, and this corresponds to this. And now what I do is I create these 4 variables, which is equal to box, and the assigning type is an integer. So this will create the borders of the square, which I'm gonna create and show you guys very soon. So I do this in the form of a tuple, and going down below, I define a variable called face, which is equal to the frame, which is nothing but just the CV2 camera, and I make a crop out of that as the face, and then I change it from BGR to RGB. I resize it, I convert the image into an array, pre-process it because it's a really important and critical step to do. And now what we do is faces which is the array defined, we append all of those faces, and now it's going to be in the form of a list. So now locations is another array which is defined, and I append start x, start y, end x, and end y. And now what I do is I write an if condition, meaning in which if the length of faces exceeds O or 0, what you do is you redefine faces as a numpy array of faces, and your d type, which is your data type, is float 32-bit. So predictions is equal to the predictions you make out of the mask net, and as I said before, the mask net is nothing but just the model we built. So predictions is equal to masknet.predict all the faces, and this is an array, and its size will be 2, and then I give this batch size. What I do here is I write a code, and what that code does is it puts a text to see the number of faces that have been detected, and the color is like purple. Now I return these two values. So now the function definition is over. Now I'm going to set up the face net. So what is face net? So the face net is nothing but just the standard model that's been created. So you're trying to read these two networks, in which this wait path is underneath the proto txt path. So these I got it from from a YouTube channel and everything, and also I got all of these information, and I learned this through YouTube videos, experience in coding and everything. So now I read this networks, and the model I use to get this is the deep neural network thing. I set up the mask net, which is load underscore model. Load underscore model is from a keras function, and this is what I saved it as. And now what I'm going to do is I'm setting up the video camera, and I write a while iteration where r is the success and frame is nothing but just the image which is going to be shown is equal to vs.read. I resize the frame in its dimensions and everything. Call this function below. So what this does is it uses two variables. One is logs and preds. Logs is locations, preds is predictions. So now what I do is I use this function and give the inputs, which I defined right above the while loop. Now I write another iteration which goes through all the locations and predictions, which is box and pred. So now what I do is the starting and ending coordinates is equal to box, which is in which this corresponds to this, while this corresponds to this. Now this two is equal to this array, preds array. So now I have given this print over here, and now I write in line number 80, I say labels is equal to this if mask is greater than without mask, else it's equal to this. Now the color is equal to this if mask is equal to mask, else it's this. And I hope you all know what I'm talking about, because this is basic things about machine learning in CV2. And equal to this, which is what I'm going to display out. And now what I do is I put this text out, which is occupying 2 lines over here. Then I draw this rectangle, show the image, define this key to be this, and if that key has to equal ORD of Q, in which ORD just converts these characters to ASCII, then I break the iteration. Then CV2 dot destroy all windows is what I do. Now I'll show you the main output.
So as you can see, this is the final output. It says that I have a mask on, and it gives the prediction just the way I anticipated. Also, it returns the number of faces it sees. So let's say if I block it, and if you can see it, it says 0 because now it can't detect the face. Well, now it can.